In this section of the bridging, we're going to look at linear and non-linear simultaneous equations. So far, you've been used to simultaneous equations and you've used linear examples, i.e. ones where we've just got x as a power of the first power of x. So we would have something like 2x plus y is equal to 4 and x minus 3y is equal to 6, something along those lines. I don't know whether that's going to work nicely. And then all we did was either use elimination or substitution, as we discussed in the last section on simultaneous equations, to solve for this. Now, elimination is not an option in terms of subtracting downwards for when we've got examples of non-linear and linear equations. So what we're going to do in this video is look at the circumstances where these may arise and the techniques to solve different examples of them. So these ones now, solve each pair of simultaneous equations. You look at them and they're all x to the first power. Now, a non-linear isn't always just a case of no x squared. For example, now if we had 3xy is equal to 2x plus 1, that is not linear because we have a product, a multiplication of an x and y. The only time it's linear is if we've got them what we call explicitly defined. So 4x, there's no xy, there's no x squared. They're just simple expressions. So we know how to solve these. On this one, we would use a substitution method, as we discussed on the last tutorial. We now need to find the coordinates of the points of intersection if given the straight line and the curve in each case. What this is saying is these are simultaneous equations. The coordinates of intersection are your solutions to the equations. Let's take the nicest example here. Y is equal to x plus 2. Y is equal to x squared minus 4. If y is equal to x plus 2 and y is equal to x squared minus 4, then x plus 2 must equal x squared minus 4. That's fairly straightforward. These two things are equal, so they equal each other. We bring everything to the right hand side, set this side to 0. We've got x squared minus x, minus 4 minus 2 is minus 6. We can now simply factor and solve this. X plus 2, x minus 3. So for points where x is going to equal 0, x will equal negative 2 or x will equal positive 3. Our approach now to find the corresponding y coordinates, that is not a solution, we've only got the x. What we now do is get our value here of the y coordinate. So y is going to be equal to x plus 2. So if x is negative 2, then y is equal to 0. If x is going to be positive 3, we use the linear, don't go back through the quadratic. X is going to, y is going to equal 5. Now let's just have a think about what this looks like graphically. The graphical representation is fairly straightforward. We've got a straight line, the line y equals x plus 2, which is a gradient of 1 and cuts just here. And then what we've got is a quadratic equation where x squared minus 4 is equal to 0. So this would look like a parabola that would do something like so. So a parabola that opens upwards, does something like this, and then comes back up that way. What we've just found are the points of intersection, and I appreciate it would be a better example of this. If you solve this, then you know that one solution is going to be 2 naught, and the other solution is going to be minus 2 naught. The point of intersection that we've got here is when x is equal to 3 and y is equal to 5. So that's 3, 5. And we know this one is 2 naught because the line y equals x plus 2 goes through at negative 2. So there we go. That is the intersection. So when you have y is equal to this and y is equal to that, then this and that equal each other. Although highly, well, it's poor, it's not technical, it works. The terminology, that is, rather than the method. Okay, let's look at some of these now. What we've got is x squared minus y plus 3 is equal to 0, and x minus y plus 5 is equal to 0. What we're going to do is make y the subject of one of these and simply substitute it in. So equation 1 we're going to write as x squared minus y plus 3 is equal to 0. And equation 2, I'm going to make y the subject and say that x plus 5 is equal to y by adding a y to both sides. We can now substitute this in and therefore eliminate y. So equation 1, we've got x squared minus y. Well, y is this total quantity here, so I can write in minus x plus 5, and then we've got now plus 3, and that's equal to 0. So I get x squared minus x minus 5, so be careful with that, x minus 5 plus 3, which is going to give me x squared minus x minus 2 is equal to 0. We can now factor this. We can have x plus 1, x minus 2 equals 0, and we can see that x is going to equal negative 1 and x is going to equal positive 2. So there are our two solutions. Okay. Another way you could have done this, again, was to make y the subject on both of them, and we'll look at that shortly. So x is equal to negative 1. Let's put it through the easy one. Negative 1, negative y. So minus y is equal to 4. So y is equal to 4. If we think about putting x in as negative 1 plus y plus 5 is equal to 0. So y plus 4 is equal to 0. And then we're going to get, negative y, isn't it? My apologies. Negative y, so y is going to equal 4. So when x is negative 1, y is 4. That makes sense. And when x is 2, 2 minus y plus 5 is equal to 0. So we're going to end up now with y is equal to 7. So the point's 2, 7. What you could have done on that one is, again, made y the subject of the top one. You could have said y is equal to x squared plus 3. And on the bottom one, y is equal to x plus 5. And if that's the case, then x squared plus 3 has got to equal x plus 5. Okay, so what we'd end up now with is the following. We would end up on here, let's just check we got this all on here. So y is equal to x squared plus 3 and y is equal to x plus 5. So we're going to end up now bringing everything to this side, and we'd have x squared minus x minus 2 is equal to 0, which is exactly what we got just here, and we would go on to solve it. That would probably be my preferred method, actually, to make y the subject on both. So either of these methods is fine. You can substitute in, or you can simply make y the subject on both. Okay, let's look at an example when we have something slightly different. Here we go. This top one is a circle. X squared plus y squared is equal to 25. What this is an equation of a circle, and I'll try and draw a circle now. This is an equation of a circle, centre 0, 0, with a radius of 5. So this is going to look something like this. Okay, so that point right there is 0, 0. This point right here is 5, 0, 0, 5, negative 5, 0, 0, negative 5. This line is equal to, if we make y the subject, y is equal to 2x minus 5. So it's got a gradient now of 2, and it cuts at the negative 5. So this line is going to look something like this, give or take. Be slightly different, but it'll give you some idea. That's what that line's going to look like. Now, what we need to do to solve this is as follows. We've got x squared plus y squared equals 25, and 2x minus y is equal to 5. Equation 1 and equation 2. In equation 2, I make y the subject. 2x minus 5 is equal to y. Now, we can't use elimination by subtracting down. So what I'm going to do is take this value every time I see a y in the top one. So I'm going to get x squared plus y squared. Well, that's 2x minus 5 all squared, and that's going to equal 25. Expanding this out, we're going to have x squared plus, and if you expand the double brackets, you'll get 4x squared. Then we're going to have minus 20x plus 25 is equal to 25. So what we can see now, tidying this up, we've got 5x squared minus 20x, and the 25s will cancel, they can go, and that's going to leave us now with 0. Divided out by 5, x squared minus 4x is equal to 0. And we've got a simple bit of factoring, x minus 4 is equal to 0. So x is going to equal 0, or x is going to equal 4. And you can clearly see that this is our point where x is 0. So x is 0, y is minus 5. And when x is 4, putting it back into the linear, we're going to get 4 times by 2, which is 8, minus y is equal to 5. So this point right here, and again, it's not entirely accurate, but that point right there is 4, 3. Okay? So there we go, 4, 3. And just out of interest, if you think about this, this is just a bit of extension. If that point is 4, 3, then what have we got here? We've got a right angle triangle. Let's put that on there. And that distance here is 4, and that one is 3. 4 squared is 16, plus 3 squared is 9. That distance, right angle triangle, root 25, which is 5, which satisfies that. So that gives you some idea. So there we go. These are examples of simultaneous equations where we have one linear and one non-linear example. We'll do one more. We'll do this one just here. This is not an equation of a circle here. X squared minus 2xy minus y squared equals 7. So what we want to do now is make either x or y the subject on the bottom. And what I'm going to do is say that y is equal to, and in terms of what you do, it's entirely up to you which you make the subject. Some lend themselves better, and after a while you'll see that that becomes the case. But if we write y is equal to 1 minus x, then we're going to substitute that into equation 1. X squared minus 2x y, which is 1 minus x. And then minus y squared. Well, this is minus 1 minus x all squared is equal to 7. So expanding out, 2x squared minus 2x plus 2x squared minus, and we've got to be careful here, we can have 1, then we'll have minus 2x plus x squared. Okay? Just be careful on that part, and then that's going to equal 7. And I am step by step in this. So we can have 3x squared minus 2x minus 1 plus 2x minus x squared is equal to 7. So we've got now, one of the x squares will cancel, so we've got 2x squared, the 2x and 2x will go, so we've got 2x squared now is equal to 1 plus 7, which is 8. Dividing both sides by the 2, x squared is equal to 4. X is equal to plus or minus 2. So if that's the case, let's put in 2 here. 2 plus y is equal to 1, so y is going to equal negative 1. So we'd have the points of intersection now of 2, negative 1. If x was negative 2 plus y is equal to 1, then y is going to be 3. So there are points of intersection and the solutions to the simultaneous equation. X is equal to 2 when y is equal to negative 1, and x is equal to negative 2 when y is equal to 3. So there we go, simultaneous equations when one is linear and one is not linear. Look at the methods, whether it's a circle, whether you can match the y's up and simply substitute in, or you need to make y or x the subject.